In this video, we are going to look at the periodic table of elements and how they differ among the various physical and properties in the periodic table. Don't forget to like and subscribe after watching the video so you can receive every bit of update from this channel. So before then, let's see the structure of an atom, which forms the basis or the smallest units of each of these elements in the periodic table. So we are going to take just one atom. So this is a sodium atom. Let's look at the various parts of the sodium atom. Atoms have basically three subatomic particles. So atoms have electrons, atoms have neutrons, then they also have protons. Now atoms have a central core which is called a nucleus. Now the nucleus accommodates the protons and the neutron in the center of the atom. Now the electrons are found in a shell. So around the nucleus are orbitals, or let's say shells. Now these shells are where the electrons are bound. So the electrons keep moving in a shell around the nucleus of the atom. Atoms may have multiple number of shells based on the number of electrons it has. For example, if an atom has just 2 electrons, it will have only one shell. If it has 10 electrons, it will have 2 shells. If it has 8 electrons, it will have 3 shells. Now the charge of an atom depends on the number of the subatomic particles, electrons and protons in the atom. Bear in mind, protons are positively charged, whereas electrons are negatively charged. But neutrons have no charge or has a neutral charge. So the charge of an atom, being it a plus, which is a cation, or a minus, which is an anion, depends on the number of electrons and the protons in the atom. Now, in a neutral atom, an atom with no charge, the number of protons and the electrons are the same. So, in every neutral atom, like let's say an atom of a sodium, which has an atomic mass of, let's say, I think 11, the protons are 11, then the electrons are also 11. But when it assumes a charge, it means either the proton or the electron has exceeded the number of the other. If the number of electrons exceed the number of protons in an atom, the atom becomes a negatively charged atom, which is an anion. On the other hand, if the number of protons exceed the number of electrons in an atom, the atom becomes a positively charged atom, which is a cation in the atom. So the properties of an atom depends on the charge on it, and the charge also depends on the number of electrons or the protons. So if it has more protons, it will be plus charge. If it has more electrons, it will be minus charge. The atoms or the protons in the atom is called the atomic number of the atom. The number of protons in the atom is called the atomic number of the atom. Now, in a neutral atom, the atomic number can also be referred to the number of electrons because the atoms, electrons, and protons are the same in a neutral atom. The mass number of an atom is defined by the mass of the protons and the neutrons in the nucleus of the atom. So the mass number of the atom is just the number of protons and the neutrons in the nucleus of the atom. So to get the number of neutrons in a neutral atom, just subtract the mass number or the atomic number from the mass number. That gives you the number of neutrons in an atom. Now, each of these elements which were discovered were all packaged or arranged in a tabular form we call a periodic table. Now, the periodic table was arranged by a system of organization we call an IUPAC. And the IUPAC refers to an international unit of pure and applied chemistry. So this is an organization as shown here. So International Unit of Pure and Applied Chemistry is an organization that came together to form or let's to arrange the discovered element in a tabular form. And the table of elements discovered on Earth and also aside it are what we call the periodic table. So this is a periodic table of elements which we are going to look at how they differ in physical and chemical properties among each other in the table. There are two alignments in the periodic table. We can have the horizontal alignment, which goes this way, and the vertical alignment, which goes this way. Now the elements in the horizontal alignment are said to be in the same period. So here the elements at horizontal alignment 1 are said to be in period 1. This one is in period 2, this one is in period 3, and this one is in period 4. So let's say lithium and beryllium are in period 2, and sodium and magnesium are in period 3. So sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, or argon, all these are in period 3, whereas these ones are in period 2. If you come here, you can have potassium and calcium all in period 4. So elements that are in the same horizontal alignment are said to be in the same period. Now, elements that are in the same vertical alignment, as shown here, are in the same group. So hydrogen, lithium, sodium, potassium, all these ones are said to be in the same group. So group 1 element, when we say group 1 element, they are elements which have a net charge of +1. So lithium, sodium, hydrogen, potassium, and rubidium, all these elements are said to be in the same group because they are all in the same group in here. Now these ones, beryllium, magnesium, calcium, are all also in the same group. So elements in the same vertical alignment are said to be in the same group, whereas elements in the same horizontal alignment are said to be in the same period. So in basic terms, on the periodic table, we can have about 18 different groups. As shown here, you can have about 18 different groups. That you can have group 1, group 2, group 3, group 4, group 5, through to group 18. So all these elements that are in the same group share the same chemical properties because they all have the same valence electron or the same charge, with the exception of differences in elements which we call a transition metals or the transition element. So let's see the element in group 1 as seen here. You can have hydrogen, you can have lithium, you can have sodium, you can have potassium, or rubidium, cesium, and francium. All these elements are said to be in the same group, and these elements are generally called alkali metals. They are alkali metals, as seen here. They are alkali because they exhibit some kind of basic properties, so they are called alkali metal. One unique feature about this element is that they all have a valence electron of 1. No, the valence electron is the number of electrons in the valence shell of an atom. So lithium, sodium, potassium, rubidium, cesium, and francium, all these elements have a valence electron of 1. And they are also called alkali metals. They are metals because they form a plus or a cation. Now metals are generally called metals. They are called so because they are elements that forms a positively charged ion by losing electron. So all these elements, lithium, sodium, potassium, rubidium, they all form just a plus charge, 1 plus, so by losing 1 electron. Bear in mind, when an atom loses an electron, the number of protons exceeds the number of electrons, hence assumes a plus charge. When an atom gains an electron, the number of electrons exceeds the number of protons, hence it assumes a minus charge. So all the elements in the group 1, which we call the alkali metals, they all forms a plus charge by losing an electron to an electron deficient species. So they are called alkali metals. In general sense, metals forms an ion by losing electrons, or metals always form a plus ion or a cation because they lose electrons to an electron deficient species. Now, elements in group 2, they are also metals as seen here. So group 1 elements are called alkali metals, Group 2 elements are called alkali earth metals. They are called alkali earth metals because they are mostly found in earth, though they also have some kind of basic properties or alkaline properties. They form a plus or 2 plus charge. They also form a cation because they are all metals. So as seen here, group 1 element and group 2 element are all metals because they all form a positive charge atom or ion. But the difference is that group 1 element forms just a 1 plus charge, whereas group 2 element forms a 2 plus charge. They all form a cation. Among them, beryllium, magnesium, calcium, strontium, and the rest, they all form a 2 plus charge because they are metals and they are called alkali earth metals, as seen here. Let's come here. We have the group 13 element. You come back to group 3. Let's come to group 13 element. To group 13 element, we have boron here. You can have aluminium here. You can have gallium here. You can have indium and tellurium. There are many. They are also metals. They form a 3 plus charge. Group 14 elements can form either a 4 plus charge or a 4 minus charge. Group 15 element, as seen here, the nitrogen, phosphorus, from here is where we start forming a negative charge. So nitrogen, phosphorus, arsenic, they are all group 15 elements and they form a 3 minus charge. So all these elements needs an extra 3 electrons to fill an octet. So they receive electron from an electron-rich species from an anion. Group 16 elements are the elements we call them elements in the oxygen family, as in here, because oxygen is their leader. So oxygen family element, they form a 2 minus charge. So oxygen, sulfur, selenium, all these elements forms a 2 minus charge because they need an excess of 2 electrons to fill an octet. We can have group 17 element. Group 17 elements are the elements we call halogens, as in here. So these elements are called halogens. They form a 1 minus charge. Fluorine, chlorine, bromine, iodine, astatine, and the rest. They are all elements in group 17 and they form a 1 minus charge because they need an extra of just 1 electron to fill an octet. Group 18 elements are the elements we call the noble gases or an inert gases, and they are the most non-reactive element on the periodic table. So group 18 elements can have helium, neon, argon, and the rest. All these elements do not undergo reactions because they have no excess or they have no tendency to lose or gain electrons. They have a fully filled valence shell, so they need no electron to fill an octet. So the group 1 element, all these elements, as we said earlier, are called alkali metals. Group 2 elements are called alkali earth metals. We can have this element highlighted here. These elements are also metals. So from group 4 to group 12, all these elements are metals, but they are called transition metals. So they are called transition metals, not like the alkali earth metals or alkali metals. The name metals comes in because they form a positively charged ion or cation, but they form a transition metals. Bear in mind, we said that each of these elements in group 1 and group 2 forms or have the same chemical properties because they have the same charge or the same magnitude of the charge, but differences in the reactions may come as a result of the atomic radius or the number of shells which surrounds the nucleus of each of these atoms. Now the transition metals or transition element, they are metals that forms a plus charge, but they have a variable oxidation state. When we say they have a variable oxidation state, it means that they can form 1 or more charges or 2 or more charges. For example, let's take an element like copper. Copper is a transition element or a transition metal which has a variable oxidation state. Copper can form a 2+ charge. It can form a 3+ charge. So based on the state or the condition of the element can form 2 charges. So it says it has a variable oxidation state. So each of these elements have a variable oxidation state. They have more than 1 charges, or they can assume more than 1 charges based on the condition they are in. Iron is a typical example, mostly found in a hemoglobin or the red blood cells of a mammal. Iron can assume a 2+ charge and also a 3+ charge. So it has 2 charges. Hence we say it has the variable oxidation state. So in the periodic table, all the elements with more than 1 charges are called transition element. As the name implies, they say they have transition. Transition just means what? Variabilities, or it changes. The change in oxidation state. So an oxidation state is when an atom either gain or lose. So the net charge becomes the oxidation state. Each of these elements are called transition metals because they have a variable oxidation state. Once again, their valence electron also ends in a d orbital. So their valence electron also ends in a d orbital. So transition elements are sometimes also called the d block element. D block element. So we have a valence variable oxidation state, or they have their valence electron in the d block. Let's have here, we can have some other metals in the periodic table that have no variable oxidation states, as seen here. So you can have an aluminium. All these elements which are painted with this color, as seen here, they are metals, but they are not transition metals because they have no variable oxidation state. Once again, you can have other non-metals as seen here. So as seen here, all these elements are non-metals. So you can have metals and non-metals. Metals are basically ones that forms a plus charge, and non-metals forms a minus charge. These elements which are painted, I think orange here, as seen here, these elements are called the metalloids or the same metals. They are called same metals or metalloids because they have both a metallic and non-metallic properties. So whilst metals forms a plus charge, non-metals forms a minus charge. And these elements have both metallic and non-metallic properties. So boron can sometimes form a plus charge or a minus charge based on the condition. Silicon is a typical example based on the condition. So they have both metallic and non-metallic properties. Bear in mind, the key feature of metals is that they form a plus charge, and the key feature of non-metals is that they form a minus charge. Let's come down here to the period here. We can have a family of elements at the period as seen here.